All right, so. All right, so number 8, oh gosh, I remember this question. This formula they give is just awful. Just remember you get a calculator for this, all right? The fuel consumption of a car in miles per gallon is modeled by, all right, and then they give this awful, awful thing. All right, that's e to the power of all of that. All right, so it says the car is traveling 50 miles per hour and its speed is changing at a rate of 20 miles per hour squared. All right, so traveling 50 miles per hour. So that means S is 50, speed is 50, and its speed is changing at a rate of, so S prime is that 20 miles per hour squared, the rate of change. The question is, what is the rate at which the fuel consumption is changing? So what they want is F prime of S. So we're going to do this derivative and then plug in the values that they gave us. Right? So E is its own derivative. So it's going to just be, you know, all of this stuff. I'm just recopying it. And then there's a chain rule. We have to chain on the derivative of what's in here. So for S over 20, you could think of that as 1/20th S. That's going to be 1/20th and then times S prime. So the derivative of S. And sorry, this is going to get kind of around the corner here because I wrote the information off to the side. All right, minus, now when we bring down the 2, you'd have 2 over 2400. So that would be 1 over 1200 S and then times S prime. And so we're going to plug in 50 for S and 20 for S prime. So this is going to be, again, really awful. So 6e to the power 50 over 20 minus 50 squared over 2400 times 1/20th times, oh, well, so 1/20th times 20 would just be 1 minus S is 50. So 50 over 1200 times 20. I'm not going to sit here and poke all that into the calculator in front of you because I don't want to waste your time. But if you plug that in, let me look back at my notes here. You are going to get 4.299, which is choice B. So you would put all of that in the calculator. Is that a fair question? I'm not really sure. I think they could have assessed that and not given such a nasty function. When really all they were asking for was a derivative and then for you to plug in some numbers to it. So yeah, that's what was going on with that one. All right, 86. So this says f prime of x is greater than 0. All right, I've been talking a lot. Let me ask you guys a question. If the derivative is positive, what does that mean the function should be doing? If your derivative is positive, what does that mean the function's doing? Good, perfect, awesome. Nice job, guys. This means increasing. So you're being asked to choose which table of values this matches with. So you want to pick one that's increasing. So A is increasing, B is increasing, C is increasing, D is constant, so not that, or no, C isn't increasing, I'm sorry, it increases and then decreases. You can get rid of C, you can get rid of D, and that's it. So you can get rid of C and D. All right, but then there's another piece of information here. We're told integral from 4 to 7, and all the charts that they gave are from 4 to 7. F of t dt is 0. So that means if you add up all the area under the graph from 4 to 7, you end up with 0. That means that you have to have some area that's below the x-axis and some area that's above so that they'll cancel each other out in order for it to end up being 0. So out of the ones we have left, A is below the x-axis all the time, and E is above the x-axis all the time. So the only one that can balance out is choice B. So that one is going to have to be B. All right, and then 87. See what's going on with 87. Let R be the region in the first quadrant bounded above by the graph of y equals ln 3 minus x. And we're on the interval 0 to 2. R is the base of a solid for which each cross section perpendicular to the x-axis is a square. All right, this is where you have to imagine these squares popping up out of the paper at you. It said perpendicular to the x-axis, so it's going to be a dx problem, and we're going to go from 0 to 2. And inside of here, you should put the area of your shape. I always just draw the shape off to the side. And the base of that shape is going to be the functions. This is ln 3 minus x. Now, since it's a square, if that's the base, then that's also going to be the height. And again, inside of the integral here, we want to put the area of this. So it would be that squared. So ln of 3 minus x squared. So this one I will type in the calculator for you because this isn't going to be too awful. For your integral, you want math 9. So 0 to 2. And then we need to start our own parenthesis because again, the ones the calculator does are going to go around all of that. So start your own parenthesis. We want ln of 3 minus x. Close that parenthesis for ln. Close the other parenthesis we started, squared, and then dx. And so that is 1.029. And so that one, look back at it, is B.